The bird feeder has been empty for 3 months. You filled it once, stood there for a while, watched nothing land, and at some point, you just stopped checking. The yard looks the same. Same fence, same trees, same driveway. Nothing has changed. Not that you can see, anyway. But something has shifted in this space. Something you can't see, can't smell, can't measure with anything you own. Here's the thing. The birds didn't leave because the food ran out. They left because your yard had already been classified at a neurological level as a place that cannot be returned to. Most people think wildlife avoidance is simple. Predator shows up, prey leaves, predator goes away. Everything goes back to normal, clean and reversible. The actual mechanism is far stranger than that, and far more permanent. Birds don't make real-time safety decisions the way you navigate traffic. They build cognitive maps, spatial threat frameworks assembled from sensory data collected over months, sometimes years. And once a location gets flagged as high risk inside that framework, the classification becomes structural. It doesn't reset when the threat disappears. It persists. Because in evolutionary terms, a safe place that suddenly becomes dangerous is almost always a trap. And evolution has been punishing the birds that ignored that lesson for a very long time. Your cat does not need to kill a single bird to destroy your yard as a habitat. Not one. University of California research confirmed what field ecologists had suspected for years. The mere presence of cat urine in an outdoor space creates a chemical exclusion zone, roughly 50 meters radius in open terrain. It expands under humidity. It contracts after rain, but it never fully disappears. The compound responsible is a felid-specific chemical marker. Bird olfactory systems, which are far more sensitive than scientists once assumed, detect it as an active threat signal, even in trace concentrations. The bird doesn't need to see your cat. It only needs to pass through the boundary. Now here's where it gets interesting, because not all birds respond the same way. Passerine birds, sparrows, finches, warblers, detect that signal and leave immediately. No investigation. No second look. Gone. Corvids do something different. Crows and jays assess the concentration gradient. They work out where the source is probably located, and then they make a calculated decision about whether to engage with that territory at all. This isn't instinct operating differently in two species. This is two completely different grades of cognitive processing being applied to the same threat data. One system runs on reflex. The other runs on something that, if we're being honest about it, looks a lot like inference. Your dog presents a different problem, and in some ways, a more insidious one. Dogs don't chemically contaminate space the way cats do. Their threat signature is vibrational, behavioral. Ground-feeding birds, juncos, white-throated sparrows, American robins, have mechanoreceptors capable of detecting substrate vibrations well below anything a human can feel. A medium-sized dog walking across a yard at a normal pace generates ground pressure pulses. These birds detect from over 30 meters away. Over a full breeding season, repeated exposure to that signature, with no direct encounter, no chase, no attack, measurably elevates baseline corticosterone levels in ground-feeding populations. Corticosterone is the avian stress hormone. When it stays chronically elevated, clutch sizes shrink, egg viability drops, fledgling survival falls. Your dog never threatened a single bird. It simply existed in the same space, and the birds paid for it reproductively, across an entire season. When both animals share the same yard, the combined threat profile doesn't just add together, it compounds. Research into multimodal threat detection shows that the simultaneous presence of a chemical, olfactory marker, and a vibrational movement signature triggers a qualitatively different neurological response than either stimulus alone. The archopallium, the amygdala equivalent region of the avian brain, activates at higher intensity and for longer duration. The location isn't just flagged as dangerous. It's flagged as actively, unpredictably dangerous. That's a specific category in bird threat memory. It means the threat doesn't sit still. It moves. It hunts. And it leaves chemical evidence of its presence, even when it's physically nowhere near. This is the mechanism behind what ornithologists informally call a cold yard, a space that looks biologically suitable, has food, has water, has adequate vegetation, but sustains almost no bird activity. The yard isn't being avoided because it lacks resources. It's being avoided because its threat classification, inside the cognitive maps of every bird in the surrounding area, outweighs its resource value. Birds are extraordinarily efficient energy accountants. A yard that costs more in stress hormones than it yields in calories isn't a yard anymore. It's a metabolic liability. Here's where the timeline becomes something most people aren't prepared for. The reclassification of your yard in local bird cognitive maps doesn't happen in a single season. It happens over years, and it happens through a social learning process that researchers at the University of So have documented extensively in corvid populations, but which almost certainly operates at a much broader scale. Birds observe each other's behavioral choices in real time. When a crow lands on your fence and sees the behavioral signature of avoidance in other species nearby, the rapid departure, the refusal to forage, the silence, it incorporates that data. It doesn't need to encounter the threat itself. It inherits a threat assessment from the behavior of others. This is cultural transmission of danger information. And it means your yard's reputation in the local bird network isn't just built from what has happened there. It's built from what others have communicated about what has happened there. Dr. John Marsluff and his colleagues at the University of Washington documented urban crow populations in Seattle, maintaining individual human facial recognition data across networks of over 1,000 birds. The same neural architecture enabling that. The capacity to transmit specific, high-resolution information through a social network is equally capable of transmitting location-specific threat assessments. When we ask how far a yard's reputation travels through a local bird population, the honest answer is, we don't yet have the upper boundary. But the chemical exclusion zone, the vibrational stress, the social transmission of threat, that's only the first layer. Because birds don't see your yard the way you see it. They see it as it actually is. Most songbirds have 4 classes of photoreceptor cones. Humans have 3. That 4th cone is sensitive to ultraviolet wavelengths, a spectrum completely invisible to us. Within that UV register, biological information that looks totally uniform to human eyes resolves into something else entirely. Urine and scent markings fluoresce. Disturbed soil carries a UV signature different from undisturbed soil. Stress compounds from vegetation damaged by animal activity leave visible traces on leaf surfaces. A bird flying over your yard is not seeing what you see when you look out your window. It's seeing a full spectrum readout of every animal that has moved through that space. Every surface that's been marked, every plant that's been disturbed. Your yard, from the UV perspective, is a written record. The cat that sat under the feeder 3 weeks ago left a document there. The dog that ran along the fence line left a document there. And the birds, reading with sensory hardware that has no human equivalent, are not making assumptions about what happened in your yard. They are reading the actual record. The question that tends to arrive quietly after all of this settles, isn't really about birds. It's about the nature of the environment you thought you understood. Every square meter of the spaces we move through every day is being continuously written on, read, interpreted, and acted upon by organisms operating through sensory channels we don't fully share and can't fully reconstruct. The ecological processing of your street, your driveway, your back fence, it doesn't pause when you're not watching. It's constant. It's detailed. And it has been running far longer than you have lived there. Your yard is not a passive backdrop. It's a node inside a living information network that has been continuously updated every single day for decades. The birds were reading it long before you arrived. They read it differently now. And somewhere in the trees at the edge of your street, that updated assessment is being quietly, invisibly passed along. When was the last time you noticed which birds used to visit your yard? And when, exactly, they stopped coming?